Today we're looking at access modifiers. You've seen some access modifiers before. The access modifier you would have seen is public, and I'm just highlighting that one now, public. You would have seen that with class definitions, and you've also probably seen it with the constructor definition as well. And you may have seen public being used in other places, and you may have also seen private being used. Now there is one more access modifier which you probably haven't seen, called protected. And I've just got that commented at the moment, protected. So there are three main access modifiers: public, private, and protected. These modifiers control access to your code. Just explaining that a bit more. So when a class, for example, is public, it means that other classes can access this class. Similarly with the function here, which is the constructor, public means that other classes can call this class's constructor. And you'll be seeing some other examples as well. So any variable or any function can be assigned an access modifier, and you will see that certain things must have an access modifier, and some things must be public as well. So let's have a closer look at this code now, just going step by step. So it's a fairly simple file, this one, and I've just got my import statements here. I've actually created my own package. Now you would have seen us importing Flash code like this, flash.display.movieclip. I've actually created a package myself called my package. So that's the name of it there. And if you remember this syntax, this is the package name. And then I've got a dot, and then I've got a star. So that means that I'm going to import all classes from the my package package. I could have done it like this, which I've got it commented out. I could have imported this class, my parent object, which we'll see later. I could have used the syntax of my package dot and then the class name, but I'm just going to import all the classes within my package. So you can organize your code into packages as well, and just make sure that when you do organize your code in packages, up here where you've got package, that's where you're going to put your package name. So I'm just going to go to my class, which I put into a package. So this is my parent object, okay, and I put it in the package called my package. So if you have any code that's within your own packages, make sure you've got package and then the package name. And on the file system, you should have a folder called my package as well. Flash expects that. So you've got your class files, your AS files. They are within a folder or directory called my package on your file system. Okay, going back to this code. So I've got my FLA file, I've got my document class called access modifiers, and I'm importing some of the packages and classes I've created earlier. And I've got my constructor here. So you will notice you've got a public, okay, for your class. Now you do want a public document class, otherwise no one can access your code. Nearly always your classes will be public. It's only on a few rare occasions when you're looking at design patterns that you would have a private class. Next thing, we've got our constructor function, which is also public, okay? So we want our code that is calling this class to be able to call our constructor to create an object. Okay, then we have this line here. My parent is the object, and the class name is my parent object. Now that's a class I've created, which we saw earlier. Now let's have a quick look at that class, my parent object. Okay, now in this class, it is a public class, okay, but we first have two variables. Now we've got a private variable there, and we've also got a public variable. So the private one I've called my private variable, and likewise with the public variable, my public variable. And these are string variables that contain some text. We can access the public variables, and we will see this now. We'll try to access my public variable. Because it's public, we're going to try and access it in the access modifiers class. So let's go back to here. Now I've got a comment here, and it says this works, but it is not good practice to access variables of another class directly. Okay, so what I'm saying there is having a public there is not a good practice. Generally, you want all your variables to be private. Okay, and I'll talk a bit more about that later. So basically, just remember that your variables should be private. Okay, and let's just run this code. So it's trace my parent. Okay, so I created a my parent object, and I'm going to try and access my public variable. So I'll just run that one, and so you should see the output. My public variable is just a string, and it just contains the text my public variable. So if I run this, just to see that it works, we should see the text my public variable. Okay, and then we have, don't worry about the second line here, we'll see that later, but you've got my public variable there. Okay, so we are able to access that public variable. Okay, now let's change my public variable there to my private variable. So remember, in my parent object, we've marked my private variable as private. Now we should get an error here because we're trying to access a private variable. And we do. We've actually got a compiler error. So it's not compiled our program. So it says attempted access of inaccessible property my private variable through a reference with static type my package my parent object. Okay, so basically saying that you tried to access something that you're not allowed to access. So I'm going to change that back. And just save all. Okay. Now, I did say before that it's not a good idea to access my public variable. And I'm just going to uncomment this one now. We're going to access my private, which failed when we did it last. But the way we're going to access it is through what they call a getter or a getter function. In my parent, there's a function called getMyPrivate. So let's have a look at that one. Okay, down here, function, it's a public function, so we can call it getMyPrivate. So, and it's saying this is a getter function. You cannot access my private directly because it is private, but you can access it through this getter. Okay, now this is a very good practice to use getters and setters. We'll see a setter shortly. Okay, and we've got the text, my private variable. So that's working so far. So this concept of having your variables private, and so this one wouldn't be public, which should be private. That's a good practice, and the concept is called encapsulation. It's where we try to hide variables that other classes should not have access to. Now we've made these variables available for our getters, but there might be some occasions where we don't want all our variables to be accessed by other classes. So we control access to this my parent object's variables through the use of getters and also setters, which we'll see shortly. Okay, let's have a look a bit further down. Okay, now these things will produce compiler errors. So I'm looking to trace my parent, my local, and the comment there is local variables are not accessible to other classes or other functions within the same class. Local variables we've seen before. Now let's go back to here. Okay, it's just in the constructor. So there, my local. So this variable was created within the constructor. It's not a class variable. It's not up here with these other two variables. It's within a function and just so happens to be the constructor. So we will get an error trying to do this because my local, you cannot access that from this class. and there we go. So just a compiler error. So we can't do that. We cannot access local variables. Private variables are not accessible to other classes. Well, we've seen this one before, just to run it again. Okay, so we get the same error as we saw before. So we tried that one before. Okay, now this one is getting a bit more complicated. But before we go to, because it's a protected function, before we go to that, I just want to talk about setters a bit. So I'll go back to my parent object. And so this is a setter. Okay, it says get. Normally getter functions have get and then the name of the variable. So get my private or get my public you could have also. Along with getters, you may optionally have setters. So this one here, it says this is a setter function. You cannot set the value of my private directly because it is private, but you can through this setter. So this function, the setter function, is public, so it can be accessed, and it expects a parameter called newString, and within this function, we're going to set the value of my private variable to newString. Okay, so we just set the value of the variable, but we use a function, a publicly accessible function, to do that. Now I've just got a note here. I put the keyword this. That's a good practice as well. Just to be explicit about, we're talking about my private variable in this class, but you could have had without this. That would have been fine as well. Okay. Now protected. So protected variables, they're a little more rare than private and public variables. Protected variables and protected functions, they're only accessible to subclasses, not to the parent object. So what does that mean? Well, we haven't seen this a lot yet, but you can have one class inherit from another class, which means that it's going to pick up, the child class is going to pick up the variables and functions of the parent class. I have got a parent object here. So this is my parent object, and it's aptly named. If I go to my child object, let's see that one now. Okay, my child object, it says here that it extends my parent object. Now, the extends keyword indicates that we're going to inherit, that's a technical term, inherit functions and variables from my parent object. Okay, so my child object is going to pick up both the publicly accessible and protected functions and variables from my parent object. You really just need to run this code to fully understand what's happening here, because inheritance can be a little bit tricky. So my child object, okay, it's got its own constructor. It's got a function which says say hello, and it says here say hello in subclass. Okay, what's that all about? This function here does not appear in my child object. This say hello in subclass is a function that appears in my parent object. So we're going to have to go back to that to see what's going on. Now this one here, what's this? It says override. Override. Public function uWhatMate. What does override mean? Well, typical everyday usage means that you're replacing a function with another function. Okay, so we'll see that shortly again. Let's go back to my parent object. Hopefully I don't lose you on this. You may need to watch this video a few times and also run the code just to find out exactly what's going on. Back in this my parent object. So remember, my parent object is the parent of my child object. So we're using inheritance. Okay, now this function here, protected function, say hello in subclass. Okay, and the comment there is, you cannot call this function directly, only through classes that are children of this class. Okay, so that's what the protected means. It means you can call it in subclasses, but not directly. What does this say hello in subclass say? And it's just a trace statement. This is me saying hello in a subclass of my parent object. While we're here, let's have a look at this public function uWhatMate. So you got uWhatMate, and all it does is trace uWhatMate. Now, if we go back to the child object, we can see here that we've got the override. It's the same function name, uWhatMate, but we're saying something different. We're saying you having a gigglemate. Okay, so in the parent object, we say uWhatMate. In my child object, we're using the override. We're overriding the function and saying you're having a gigglemate. Now let's run all this. So there's two concepts that we're introducing here. One is inheritance, the parent and the child, but also the idea of encapsulation, which is through the use of access modifiers. Okay, I might just comment these out because they're not relevant at the moment. Save all these and run them. Let's have a look at this. So we've got a variable, myChild. So we're creating the child object, and we're saying the type of the child object is actually my parent object. Shouldn't that be? You would expect that you would have to have that. Okay, so we're creating a child and the type is my child. Well, actually, you can have my parent object there, okay, because my child object is of the type my parent object. So that's a valid, this is a valid variable declaration. So that's perfectly fine. So we create our child object, and then down here in our child object we say uWhatMate, okay, and the output you get is you having a gigglemate, because remember, parent object had uWhatMate, but the child overrode the function and said you having a gigglemate. Okay, so hopefully that makes sense. This idea of having a parent type, but in the variable declaration, so my parent object is the data type given to my child in the variable declaration, but the actual type is my child object. Now, I won't fully explain this now because we've gone on long enough, but what's happening here is a concept they call polymorphism. That's where you can have one parent, okay, one parent, but you could have many different children. So we've only got one child, but we could create my child object 2, my child object 3. So we could have many different child classes which extend or inherit from my parent object, and that whole concept is called polymorphism. So polymorphism means many shapes. So poly means many and morph means form or shape. Polymorphism is where you have a reference to the parent, but the actual class that's running is a child object, and you could have many different types of child object, but still have the reference to the parent object. Okay, very confusing. We'll see about that later. So we've had a look at uWhatMate now. Now let's just go back to this one. So I've got this one here, I've just uncommented, and it said my parent dot say hello in subclass. Now remember, my parent, we are talking about the parent object now, okay, not the child object. And we said say hello in subclass. Let's go back to that. Say hello in subclass is protected, okay, so this should fail because say hello in subclass is a protected function. We should get an error. Okay, and we do, good. That means we've tried to call say hello in subclass, which is defined in my parent object. However, it's protected. So we can't call it directly, we can only call it in subclasses. Now let's try that, calling it in a subclass. I'll just comment that one out and uncomment this one. So now we've got a reference to the child object, my child dot say hello. and just have a look at that again. In the say hello function, all it does is call say hello in subclass, which was defined here. Okay, so let's run this now and see the output, and this should work. Okay, it didn't work. The reason for that is we've actually got to, this is due to polymorphism, we've actually got a reference to the parent object here. We actually have to change that to my child object. Can be a bit confusing. Okay, so the actual data type of my child is defined as my child object. So now this should work. There we go. And we have the output, which is, this is me saying hello in a subclass of my parent object. This was a very long tutorial, the longest ever, and you will need to watch it a couple of times and run the code yourself. But it introduced three very fundamental concepts to object-oriented programming. So the first one was access modifiers, and the technical name for that was encapsulation. Okay, so using private, public, and to a lesser extent protected to control access to variables and functions. So that's encapsulation. Second concept we introduced was inheritance. So we looked at my parent object and also the my child object. So an inheritance occurs through the use of this extends keyword. And the final concept we briefly looked at was polymorphism. So we looked at how you could have a reference to a parent. So my child is actually of the data type my parent object, but the actual type or the real form of this my parent object is this particular child object. Polymorphism, and that can be a little bit confusing. There is just one more concept that's fundamental to object-oriented programming, which is called abstraction, and we'll have a look at that one next.